So 4 2s times each other, I'm betting is what you meant. So you said do 2 times 2 from that first 2 squared times 2 times 2 times 2 times 2. This feels like when your younger siblings just like trying to annoy you. And they're like, 2, 2, 2, 2, 2, ma, 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 ma. Like when you just repeat, so instead of saying mom 12, 15, 100 times like your little siblings might do, I don't know if y'all have ever had little siblings that do that, but I'm like, I heard you. What could we write instead? Yeah, mom to the power of 10, right? Or here, 2 to the power of 6. Now, I don't know that will actually work and like gain you any sort of momentum, but your parents would probably appreciate if you didn't say their name over and over and over and over again. So, Oliver, what about the 3s?
So I did 3 7s. So like 3
No, you
times.
didn't. 3 7s?
Oh, my bad.
I think you just said it wrong, but you definitely didn't do 3 7s.
Sorry.
Sorry, what you said is I did 3 7s.
Oh yeah, I did 7 3s.
So, you did what?
I did
Like, say it out.
7 3s. So 3 times 3 times 3 times 3 times 3 times 3 times 3.
Are we starting to see the point of powers? Because, and like, sometimes it feels funny, sometimes it feels annoying, but like, I don't even want to write those. Right? Like, Oliver said them, thank you, Oliver. Like, how many is he going to have in total after he writes all of them and writes all of them? What I write here? 3 to the... So I think we can start to develop like a strategy or like a trick or a technique or like a law about what to do with these exponents. So x to the 3rd times x to the 5th. Kate, what do you think we're going to do with the 3 and the 5 with those x's? Same thing we did here, we do what? We add them. So without having to write out all the x's, I think based off what we've seen, and of course, right, as soon as we develop a strategy, then they make it harder. So Sasha, now I've got x's and y's. Can you give me any advice on what you think we should do here?
Well, I kind of did what was going on up there, but with different, like...
Bless you. Did you try to, like, stifle it? It sounded painful. Are you okay? Oh, blew a flat tire over here. Alright.
I did 3 x's times 2 y's times... I didn't get as far as the x.
So you had, like, x, 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 y, y.
Then x, y, x, y.
Ooh, careful.
Oh.
This is not... You're going to have to look up here to understand what I'm saying. That's not that. This is x to the 3rd, y to the 2nd, x to the 1st, and y to the 2nd. Because if there is no power shown, like, guys, this is 2 to the 1st. That's 3 to the 1st. This is x to the 1st. I know the x and the y look like they're together, but how are letters combined when they're right up against each other? Multiplication. Guys, this multiplication dot, if we're going to show that one, we should also show this one. We should also show this one. This is really x cubed times y squared times x times y squared. They only show you just one of those dots to mess with you and open a trap door, hoping you'll fall in it. That x is not squared. The y is squared. The x is just multiplied. So how many x's do we have in this multiplication in total? 4. So we have x to the 4th. How many y's?
4.
Y to the 4th. And you could put a multiplication dot between them if you want to, but you do not have to. Now, we could, since they're both to the 4th power, we could actually just make this x, y, but in parentheses to the 4th. I want you to double check what you've written down for the last 2 there, and then maybe cross-reference that with this other gift I have for you that's not quite as sweet as the other. It is serious. Here is everything you need for this chapter. Also, why it's only going to take us a week, well, why this is a page is this chapter is only a week of content. There's not a lot here to learn. So, now guys, yes, some of you might be like, I really hate this spacing. This was the best I could do to fit it all on one piece of paper. On the front, we have our section on exponents, which a lot of us also know as powers. You don't really have to write that. It's for repeated multiplication, right? But then we make that more difficult, and we get into the rules about multiple things with powers. Flip to the back. Check out this box at the top. I like reorganized some of them, so you might need to check like under or around, because I was trying to make the room look decent last week. We had like the Phoenix Discovery Night. One of the biggest trap doors when working with powers. If I give you like 25 to the 0 power, what is it?
0.
See how many of you said 0? That's wrong. A 0 power. Guys, what is a positive power? If we flip back to here, what's a positive power doing? Like, what's its point? But like how is a positive power working? What is it telling us to do? What it's what? It's repeated multiplication, right? It's repetition of multiplication. So 2 to the 4th means you've got 2 times 2 times 2 times 2. But what if I made that 2 to the negative 4th? Okay, flip to the back again. Look right here, bottom right of the box. So powers can also be used to divide. Check this out. Let's see if I ever get let. Nope. And did I really just close it? Check it. There's always a 1, like, in front of everything. 1 Owen, 1 Cora, 1 Sasha, right? We just don't have to say it. So what does this negative power tell you to do? It says, hey, divide by 2 4 times. So this is really 1 over 2 times 2 times 2 times 2. But still, how do we get to that 0 power? Well, guys, imagine if you had 2 to the 4 over 2 to the 4. And that is what 2 to the 0 power would be. This is how this happens. A 0 power, see some people not paying attention, they'll be the people that struggle on the homework. A 0 power means you have as many multipliers of that number as you do dividers of that number. So if you have 4 2's on top multiplying and 4 2's on bottom multiplying, 2 times 2 is 4, times 2 is 8, times 2 is 16. This is 16 over 16. What's that? 1. So this set up a law, an exponential law, that anything to the 0 power is 1. Okay, except for maybe. What about 0 to the 0 power? So 0 to the 0 power would be 0 over 0? But what's the issue with 0 over? Well, we can divide 0 by, but we can't divide by 0. Right? So I agree, we can't divide 0 by 0 because of the second half of the statement. But like, you could have 0 on top. It's the 0 on bottom. You can't divide by 0. Or we listen to that thing about Cookie Monster and he's sad because he has no cookies and you're sad because you have no friends. Right? That thing. Yeah, see, that's why you can't. We don't want to have no friends. We don't want to have no cookies. We can't divide by 0. All right, so back to here, because I don't have a ton I want to cover today, but more than what I have gotten Alex, what here then could you help me with? This one's tougher.
So I'll put like 7 times 7 parentheses.
Yeah.
Then times in parentheses x times x times x, and then times 7. Then times in parentheses x times x.
Okay, so when we get over here, how many 7s in total do we have multiplying?
3.
So 7 to the 3rd. How many x's?
5.
X to the 5th. Excellent. Hannah, what about our final one there?
So I kind of rethought it after you said the thing about like how the x is the 1 and the xy.
Mm-hmm.
So I have to like rewrite it, but buffering, give me a second.
Is there a part that we're confident with? Like the x's, the y's,
Yeah,
the
it's-
numbers?
2, you want to put it in parentheses, and then times x times x times x x in parentheses,
Okay,
times 3
okay.
times, and then it would be x times, it would just be times x, and then it would be another times x, and then it would just be times y times y times y times y.
Careful. I think you had a few too many x's and y's there. So if we expand this out, it's 2 times x times x times x times x times 3 times x times y times y. So can the 2 and the 3 join up using exponents? Because what would 2 times 3 be? 6.
I knew that.
So 6, it's alright, we took a week off of math. Times how many x's? So x to the 5th. How many y's? Y to the 2nd. So guys, not everything has like exponent shortcuts. Alex? Because we put the 2 and the 3 together by just doing 2 times 3, but exponents didn't help us at all.
Oh.
So you might want to grab a highlighter for your paper and like let yourself know, like, yeah, these are how we get here. What? Oh, those are ones because it's only to the first power. It didn't show us a power. So here, these, we just wrote that they are only to the first power. There's no repeated, there's no power shown. But guys, a power that we don't see is power of 1, right? Because everything is to the power of 1, unless we're told otherwise. Is that what you're asking about? The little tick marks that I had made? Those ones? Yeah, they were ones. So, alright, so let's try this out. This is on your paper. Try these two questions, B and C. Try B and C. Yep, those are on your paper. Try B and C. Do they look like they're identical? Do they look like they're different?
Hi, Mr. Rushan. I just wanted to let you know that D&D will be canceled this week.
Oh no.
Mr. Pumped is out of the building. Thank you.
I guess I could just do this up at the board.
Pardon the interruption. Elsa Hayes to the perioperative. Elsa Hayes to the perioperative.
Henry would be. What do you think we can do with B?
You can, what I would do is add the exponents, but I would not try calculating that. So it'd probably be like larger than life, so it's just not worth it.
So, funny you should say that. There are certain numbers that will break our calculator. And it makes it go E. No, what? There's an E? What the? There's an E. But that doesn't just mean exponent, because this is not 2.25 to the 66. Like, that's super complicated. What does this E mean? But, I mean, Henry's absolutely right. I would not try to calculate this. This number's astronomically large. This number has 66 place values before the decimal point. There are 66 places before the decimal point, and that's only one of those numbers. So guys, what Henry said is right. If you look at the laws, your exponent laws, when the bases are the same, they're both 20, we can just say, okay, the base is going to stay the same. What happens with powers? Well, we add them, and we will get 20. That's still the highlighter. We will get 20 to the what?
63 pounds.
And that is an even more astronomically large number. Now, C is where we're going to get around to figuring out what did that E actually, like what was that E in the calculator doing there? So one of your teams, or 10 to the third times 5 to the fourth, is obviously 50 to the 7th. They're using their rules. Of course, Elsa's card comes up right now. Bye, Elsa. So, Kylie, what are you thinking about C? Do you think they're allowed to do that?
Let's skip. Or pass it on.
I like that you don't know if you think they're right or wrong. Let's pull on that for just a little bit, okay? So, this team... Guys, this is where, like, the rubber hits the road. I know. We're about out of time. This team said this... Hey,
Okay.
it's fine. We can just leave it, and I can finish teaching. This team said this equals this. If you want to check this, and this is where we're going to pick up tomorrow, we could calculate what is 10 to the third. Stop. I'm still talking and teaching like you're making it more difficult. Just chill
Can I
for a
please
second.
have Madeline Neal to the Perry office?
I get this, I
Madeline?
must need to
Thank
leave,
you.
but like, I gotta finish this. So if you want to check this, we put it in our calculators, do the math, and then we check it, and that's what we'll do tomorrow. But if you come to me asking homework questions, I'm probably not going to answer them because we're not done with this lesson. Okay, have a great day.
I know.